Hi, in this video I'm going to be looking at 5 different circle theorem questions from the Edexcel 9 to 1 GCSE higher papers. So, this is the first one. The points A, B, C, D lie on a circle. CDE is a straight line. And then we've got some of these conditions down here. Work out the size of angle ADE, so this angle here. Okay, you must give a reason for each stage of your working. So, every bit of information that they give you in the question is important. So BA equals BD, so we can see that this is going to be an isosceles triangle. So this means that these two angles are going to be the same, and with it being a triangle, all of them should sum to 180. So these two must be worth 140 degrees in total, so 70 degrees each. Okay, what else do we know? So the reason for that, is an isosceles triangle. Well, we also know what this angle is, because opposite angles in a cyclic quadrilateral sum to 180, so that's going to be 110 degrees. Okay, so if you were to write a reason, it's a little bit difficult for me to write on here, but it would be that opposite angles in a cyclic quadrilateral sum to 180. So once again, we've got another isosceles triangle, so these two angles are going to be the same. So 70 degrees is what's left in this triangle, so they're going to be 35 each. So that's 35, and that must also be 35. Now CDE is a straight line, as it says here. Okay, so these angles must all sum to make 180. These two sum to make 105, so this remaining angle must be 75 degrees, because then they'll all sum to make 180. Okay, next question. A, B and C are points on the circumference, as we can see. Right, and we're after work out the size of angle CAO. CAO, so this angle here. Okay, well, first things first, we've got a tangent, as we can see, and OA is a radius. So we know that this will be a right angle, because a tangent meets a radius at a right angle. So we'll know what this angle is. Our right angle is 90 degrees, so this must be 34. Now, as this is a radius and this is a radius, then what we've got is a isosceles triangle. So that must also be 34. Now what I'm going to want to do is actually make another isosceles triangle here. Okay. Well, we know that this angle is going to be 35, which means that this angle here, 35, 70, 110. And this angle here, 34, 68, 112. So this angle is going to be a full circle, 110 at 112, and that's 222, I think. Yeah, 222. And a full circle is 360 degrees, so we're missing 138. Now, as this is an isosceles, these two angles are going to be the same. Okay, so what are we left with? We're left with 42 degrees. So half that, both of these must be 21. So that's our answer. Okay, next question. Right. So angle ABO equals X. ABO this angle here is x. Find the size of angle ACB. Right. Now, tangent, radius, right angle. This is two radiuses, so this is an isosceles triangle, so that's also x. This angle here, well, they would all sum to make 180, as it's a triangle. So this angle here must be 180 minus 2x. This angle here, well, these two need to add to make 180. This one, sorry, this one here is 180 minus 2x, so this one's got to be 2x, because then they'll both add to make 180. The 2x's will just cancel out. Well, we've got 90 degrees at the moment down here. So these two angles are going to add to make 90. So this angle has got to be 90 minus 2x. Okay? So that's what I said. Right, another one with a tangent. So whenever there's a tangent, it's normally a good idea to, oops, it's not going to be there, is it? It's normally good to draw on the right angle, so I'm just going to put that in there. Show that y minus x equals 90. So what would be a good idea is if we could get this angle in terms of x, because we know that the angle at the circumference is twice the angle at the, the angle at the centre is twice the angle at the circumference. So this is going to be x, as it's an isosceles triangle. So this here is going to be 180 minus 2x. Now, this angle here, well, this plus this will equal 360. So what do we need to add to this to make 360? Well, we need to add another 180. So that'll make 360, but we've got this minus 2x, so we need to get rid of that, so add to 2x. So, the angle at the centre is twice the angle at the circumference, yeah, so 2y. Well, I can rearrange this to 180 equals 2y minus 2x, and then divide both sides by 2. 90 equals y minus x. And there we are. Right. Dylan was asked to give some possible values for x and y. He says that y could be 200 and x could be 110. Is he correct? Well, x couldn't possibly be 200, so x couldn't possibly be 110, because these two angles would then sum to make 220, which in a triangle, all the angles must sum only to make 180, so that won't work. But also, if y is 200, well, in this triangle ADB, well then this would be already over. So that's 200 degrees, then that's already over 180 degrees, which is what a triangle would be, so it can't be that. Okay, so no, you can't be correct, because those angles are too big. Okay, they wouldn't make sense with our triangles. Right, finally, ABC are points on the circumference of a circle. Prove that angle ACB is 90 degrees. You must not use any circle theorems in your proof. Right, so let's just draw a radius on here, so we've got some isosceles triangles. Right, now what would be a good idea is just give an angle a name, so call this one X, which means that this one must be X, which means that this one here must be 180 minus 2x. Now this is a straight line, so these two must add to make 180, so this one must be 2x. Now this angle here is going to be the same as this angle here. Now all of them will add to make 180, so what these two angles must be, they must add to make 180 minus 2x, because then all the angles in the triangle add to make 180. But as they're split between two, then each of these is going to be 90 minus x. So this is 90 minus x, this is 90 minus x. So, well, angle ACB is those two angles added together, isn't it? It's x plus 90 minus x. So ACB equals x plus 90 minus x, which, well, just equals 90. And there we go.